Okay, so we're almost done with kind of setting up our programming guide for how we're actually going to enter our code into CNC Motion. So this one, we're going to be talking about relative programming. Hopefully you watched the kind of the intuition video on the difference between absolute and relative. This video is going to focus on how do we get the tool to program in relative terms, okay, as far as our initials here. So I'm going to use the same initial layout that I did before with the same letters. You can do the same thing. The only difference is that in relative, I just want you guys to get the idea behind it. We're not going to go into how to do curves in relative programming. I just want to get you introduced to what the concept of relative programming is. So when we're talking about going from G to H, it'll just be a straight line. And same thing with H to I and this whole curve, it's all going to be straight lines. So there's going to be no curves in your relative programming. So just remember that. You can use all the same points, but any of your curves are now going to be straight points. Okay? So keep that in mind. So things that you will need for this video: your planning tool, your planning sheet, your code planning sheet, and then your coordinates that you have for your letters. Okay, I'm only going to go through how to do letter A because everything else is just going to be a repeat of like, oh, I've got to go from this point to this point, and this point to this point, and this point to this point, and so on. And we don't need to go through all of that. I just need you to get the idea how to get this, and then you will need to program on your own anyway how to do this one, the other two letters, okay? So when you do finish your program, we are going to pull the bit above the part at 333. Okay, so we're gonna have that part go up to X, Y, and Z 333. All right, so that's gonna be X, Y, and Z. We're just gonna call that home for right now. Okay. All right. So first off, your planning tool is actually all the same for the first 5 or 6 lines, or for the first 5 lines as your last one. Even line 3 where it says go to rapid above point A is mine. It starts at 0.3125 and 0.3125, and that's just A right here. That's 0.3125, which matches up with my 0.3125, 0.3125 right there. Okay, so once we have that, we are going to go plunging above the part, and then we're actually going to mill into the part. So we know that we're in the part here because it's negative. All right. So now we're going to, in the next line, this is where it becomes different. We're going to change it to G91. And if we look at our reference guide, we're going to look down here at G91, and it says incremental coordinate system. So I've been calling it relative, and it's interchangeable. It's known as incremental coordinate system. So I've written in the comments that we are telling the program to read it in terms of incremental or relative. Okay, so your comments are required for me. If you write code without comments, I will not accept it. You will get a 0 until you put your comments in. But once you put your comments in, I'll be happy to regrade it. Then we're going to start with our next line, N07. Okay, we're going to go a G01. Okay, so we're just going, if we look at our reference, that's a linear interpolation. Okay, I'm not going to go back to this every single time we do G01 because we're going to use it pretty much exclusively from here on out. Okay, so G01, and we are going to go to point B. So write your comment in, and we're going to go up to point B. So if we look at point B here, okay, and this is where it's handy to have a calculator ready to go. We aren't just going to write in 0.6250 and 1.6875. Remember, when we're talking about relative, we're talking about the distances between the two, right? The distances between this and this. And in this case, where I believe it's just moving another 0.3125, but all you have to do is subtract that distance, those two numbers from each other. So we're going to go 0.6250 minus 0.3125, okay? And so you can see that our answer was 0.3125. So in the x-axis, we increased it by 0.3125. So on the x-axis, we went 0.3125. So the y-axis, we're going to say, what is 1.6875 minus 0.3125? Okay, and we have 1.375. So we are traveling up 1.375 inches on the y-axis. So we've just told the machine that on the y-axis, on the x and y-axis, we're going to add two things. On the x-axis, we are going to add 0.3125, and that gets us to the middle, and then 1.375, which gets us all the way to the top of our letter A here, to point B. Okay, so now we're done with that line. We're going to go down to the next line, which is N08, and we're still in G01, straight line, and we're going from B to C. Okay, so from B to C, clear with that, right? I did. We are adding a certain number, right? So if we look at what we're adding, here, we have from B to C, we are adding, well, we just subtracted here, 9375 minus 0.6250, and we get 0.3125. So we're adding 0.3125. And this is where it gets a little tricky right here. So we are decreasing the y value, right? We're actually going down on the y-axis. Okay, so it's traveling down the y-axis, decreasing it. And decreasing, of course, means subtraction. So we're going to have a negative number for the y-axis. So negative, and let's figure out what that number is. Well, the nice thing about linear interpolation is that if you went up 1.375, you're going to go back down 1.375 because A and C are actually on the same line, right? A and C are at here and here. So to get to B, we went up, and to get from B to C, we go back down. And we're going back down that same distance, and I'll prove it to you here. So if we take 0.3125 and we subtract 1.6875, we're going to go down 1.375. Okay, so you'll start seeing the same numbers happening over and over again. All right, and so this is to point C. All right, so now this is where it kind of gets tricky on your when you have to actually come back out of the part. All right, so we need to go from point C to point D. But if we go from point C to point D right now, you're going to mill a line from there to there. So we've actually got to come up above the part and then go over and then plunge back down into it. Okay, so we need to actually go above part at 1/10 of an inch. Or 0.1 inches. Okay, so 0.1 inches above the part. Again, we're talking about relative here. So you have to figure out where you came from. Okay, and we're coming from milling in the part at 0.0625 on the z-axis down. So you actually have to go, so we're going to go G01, and we're going to go on the z-axis. I'll give you a second. What do you think we're going to add? How far are we going to move up? Are we going to go to 0.1? No, 0.1 would actually only take us to about 0.94. So we actually need to go up 1.0625. Okay, so we need to, the 0.0625 is this right here. So again, if we think about it in terms of, I'm going to do a terrible drawing here, but that's all right. We're in the part right here, right? there's your block, there's your bit, and this distance is negative 0.0625. Okay, so we're down in the part there. And we need to go above the part at 0.1. Okay, so we need to get 0.1 above the part. Then the distance from here to here is 0.162. Did I put, sorry, it should be, let me correct that there. There we go. It should be 0.1625 above the part. So sorry about that. Got my place value mixed up. So we want to go up above the part 0.1625. So again, that distance right there, obviously it helps to have a visual, it helped me. So our distance is -1 down into the part right now. We need to travel all the way up to this line. So if we only went up 0.1, we would only go to here. And we'd be missing that 0.0625. Okay, so above the part, and we're got to make sure that we're still at our speed rate, our feed rate of F9, and then we're going to keep going. N10, and we're at G01, so we're still above the part, and now we can move to part D, for point D. Okay, so A, B, C, D. So now we're at point D, and we're above the part. Now we've got to mill down into the part. Okay, so point D is at 0.500 or 5,000, and then Y value is 0.9375. Okay, so you have, again, you've got to think about in terms of the distance that you're traveling, not how the actual point that you're going to. So how far is it going from on the x-axis? How far is it going on the y-axis? So we are decreasing on the x-axis. So again, you're going to want to subtract that. So we have 0.5000 minus 0.9375. And so we're actually going to decrease our on the x-axis by negative 0.4375. And we are going to increase on the y-axis so we're going to take 0.9375, we're going to subtract 0.3125 because this is where we were, this is where we're going. And we have adding 0.625 on the y-axis. Okay, and we're not going to plunge in on this yet because we just want to go above the part. Okay, and we should put over here we're above part. All right, so next up we need to start plunging into the part. So we're going to go G01. Okay, and because we had to go up 0.1625 above the part, we're actually going to go negative 0.1625 into the part. And that point, okay, you're going down into the part, this is actually in the part at negative 0.0625. Okay, so we actually are in the part, we're back into the part at our negative 0.605. So we said that we were up here. Remember, we went 0.1625 to get above the part, and we're going to go back down into the part on the negative at that same distance. So we're going to see this distance pop up every single time we go up and down, above and below the part line, okay, or the stock line. So next up, we have N12, and now we are milling in the part, and we need to go to point E, okay? We're going to go to point E, and point E, we're going to go G01, we're going to go to point E, and we have point E at, let me look at my reference here, look at point E, we're going from 0.5000 to 0.7500, and that one's actually a pretty easy one to do in our heads. That is just adding 0.2500. And the really nice thing about relative programming is that we actually can leave the y blank. You don't have to change the y at all. It's 0. And because if you look at my change from D to E, they're the same exact number. There is no change in distance. So all it did was move 1/4 of an inch across, and now it's at point E. Okay, so now we are ready to actually, I'm going to pretend that we're ending the part. Let's say it's our last initial. Of course, you have to do 3 initials. I'm only going to do the 1. So now we're here. I'm going to end the program, all right? So you can end the program in a couple different ways. If you want to turn it back to, if you want to change back to the absolute programming to end the program, I'm fine with that. It's not really a wrong way to do that. And so now we're going to go N13, and we're going to say we're going to move above the part to a safe distance, which is above part. So above point E. And that's going to be adding at Z.1625. Okay, again, that's that same amount, right? So Z.1625. And we're going at a slow pace. And then we're now above the part. So I'm going to extend this down a little bit more. Run out of space here. Okay, so we have N14. And I'm actually going to change it back to absolute coordinates. Okay, so we're going to go G90. Okay, and then we're going to go to our next line, N15. And I like to keep them separate just because you can do some of these on the same line, but it's nice to be able to look at one line and keep it simple. Okay, so we're going to go to absolute coordinates. And then N15, we are going to go, and we can, now that we're above the part, we can go rapid traverse, which is GO, sorry, I gotta look at my reference guide, just making sure I'm not, rapid traverse at GOO, that's right. And we're gonna go to our safe position of 3, 3, 3, and then there's 2 more lines that we're going to do. N16 is going to be turn spindle off. And so we're going to say in our M code, we're going to go turn spindle off at M05. And then we can end the program, and you just do another line, and it'll be another M code of M02. Okay, and then the program will end automatically. All right, so that's pretty much it. Like again, you've got to think about the distances that you're traveling for relative as opposed to going to a certain point. So make sure that you've got that mindset when you're talking about your relative programming. In the end, when you put it into CNC Motion and you test it, you'll figure out real quick where your mistakes are, because your tool will just start going crazy all over the screen, and you're like, well, I don't know what happened. And you'll have to at some point go back to each line of code. So good luck. Let me know if you have any questions in class.